I keep saying I'm gonna do it, like I'm gonna make some kind of like pre-flight checklist, so I actually do the things I'm supposed to do before I start the stream. I think I did them all, but I need to I want like switches that I flip, like I'm a pilot in a cockpit. Hi, I'm Scott. It's me. This is our second like official residency stream, one that actually has a topic that I thought about somewhat, just a little bit before I open my mouth. So the first most important thing to do, as usual, is to pick some wallpaper to look at. I'm a little afraid to do it while looking at the screen because who knows what will come up. Let's risk it. We're gonna trust Unsplash. It's not bad. We're still looking at all these Norwegian. Well, that's just nice. A walk in a park on a nice May morning offers quite the amazing scenery and subjects to capture. I instantly fell in love with how the sunlight touches these leaves, and it's something that had to be captured. Well, that's Daniel Sandvik. I like it. It's nice work, Daniel. Okay, so what are we actually going to talk about today, now that we have some nice leaves to look at? Maybe we'll just look at the leaves. Should we just look at the leaves? Okay, everything seems to be in order. So we're going to start talking today, and we're going to start talking about a subject that you've probably heard me talk about before, if you've heard me talk before, because I talk about these things a lot. But I'm going to try to boil it down into a real simple starting point. So let's find, not that thing. What thing do we want? Where's the thing? There. Wait, the wallpaper changed. I didn't do that. Okay, well, the wallpaper accidentally changed, but fortunately I like that. Yes, okay. So today we are talking about getting started in creative technology. And as I mentioned last week, well, okay, what were we actually saying? So building on our Tuesday discussion, I'll talk about some tools and devices that can make it easier to get started working with technology in creative ways. And I actually prefer that phrase, like working with technology in creative ways. It's a little less loaded because like we talked about a little bit last time, creative technology is like, or creative technologist particularly is a slightly loaded term. Like it has some connotations that are not my favorite, but not bad connotations, just connotations that aren't my favorite. So I wanted to just go through and just do kind of a high level overview for anybody that would like to watch to give a hint on like how to start doing the kinds of things that I do. Because again, like I mentioned last week, I grew up in Amarillo, Texas. I went to Amarillo High School. There just wasn't a notion of creative technology really. Like it kind of didn't exist. That notion of design barely existed. There were art classes and there was like computer club, but like in general they were pretty specific and pretty isolated from each other. Like in computer class we just wrote simple Pascal programs, and in art class you did your drawing sketchbook. There wasn't like a lot of overlap. And now it's changed, and there's tons of tools and there's tons of resources, and it is relatively easy to get started. And it can be inexpensive. It can even be free depending on the devices you have available. So the first thing I just want to say is like anybody watching this is capable of doing these things. It may seem daunting, and certainly some of the hardware and software stuff can get really complicated, but that's like anything can get really complicated. Just because you can't paint a fresco on the ceiling of a cathedral, or I don't know why you necessarily think that. Just because you can't like sculpt some masterpiece in marble doesn't mean you can't enjoy sketching. Or just because you can't work on the ceiling of the Sistine Chapel doesn't mean you can't enjoy doing some figure drawing or something like that. So just like any creative endeavor, there's places to start, right? Like you don't have to be able to compose a symphony to sit down at the piano and learn some simple songs. So try having that same mentality. Like yes, the difficulty scales very high, but that's true with the piano also. That's true with painting also. So that doesn't mean you can't start, or that it's over your head, or that you just try to check those feelings. So I'm gonna just a really high level overview, and some of these are kind of slightly random thoughts, but there's Drackland, hello. Look at you. You're resub from Drackland for undefined months. I still don't know why that doesn't work. It kind of works. Okay, there's a good example of creative technology slightly failing. My robot that watches for subscriptions doesn't work. It kind of works. It doesn't utterly fail. It works like 80% of the way. Draclin, thanks for stopping by. So these aren't like, none of this is prescriptive and none of this is like truth. This is all just my thoughts on things. So I should probably qualify by saying that. But my high level overview of this world of creative technology. So one thing I do want to say is, even if you feel like that this isn't necessarily for you, like there's something about that route that isn't interesting, I do want to say that in everything that I do, design and production software, common design and production, let's even say practices. Oops. And I say that because, if you're interested in making video games, you might be daunted because you're thinking like, oh man, to make video games, I need to learn to be a programmer. Well, that's not really true. Like, yes, there's a lot of programming that goes into video games, but there's a lot of art assets. There's a lot of 3D assets. There's a lot of 2D design assets. There's a lot of animation. And those things are done with relatively traditional tools. Almost any project I work on, no matter how complicated it is, I'm still using tools like Photoshop and Illustrator, After Effects, Maya, like those kinds of things. So I guess the point I want to make is like, if you do feel like you're a creative person and you're interested in the arts and you're interested in those tools, then there's still room for you in this world, especially on big projects like a video game where it takes a lot of people. In general, what I'm going to talk about today is more like if you want to do the thing, but I think don't be turned off by it just because it's like, oh, I hate computers, I hate math, I hate programming. Like, there's non-programming things that you can do. And there's actually lots of tools you can use. I didn't even put these in this presentation, but there's lots of tools you can use that are kind of not programming based to do creative projects that are worth talking about. So maybe we'll cram those in. And I should even say there's a million jobs for example, in video games, if that's just as an example of something you might love. There's producers and managers and finance people and CEOs. There's all kinds of, there's business people, marketing people. There's all kinds of other jobs that are in that field. So I think something, you might love football and realize like you'll never play for the NFL, but like you can still love it, and maybe there's still some way that you can work in that world. So if you want to, just like if you love movies, maybe you won't be a director, maybe you won't be an actor, but you can there's still a ton of other jobs that are available to you. So just keep that in mind as we talk through this stuff, that even if the specifics of what I'm talking about don't really appeal to you, but you do like the idea of interactive things, there's other work to be done. And kind of on that topic too, I want to say, this really is but everybody I know who works in this realm very, very rarely start totally from scratch with the hardware and software that we're building. So, because I think that's another thing that's kind of a misconception and maybe seems really daunting, is like, oh my gosh, I can't program, or I'm afraid of working on electronics and electricity. It's so rare that we start from scratch. Just like if you're a person, if you're a visual artist and you paint, right? Some painters do, but many painters, I assume, this is an assumption, when it's time to make a painting, many painters just go to the art store and buy a canvas and buy some brushes and buy some paints. That work is done for them. Like, they don't have to do that. Now, there's a million reasons why you might want to do those things or choose to do those things. Maybe you need a really special brush that's really particular to what you're trying to create, or you need a canvas that's a weird shape, so you have to make it. So you have the option to go as low as you want, but you can start kind of really high level and be like, okay, I don't want to worry about how paint is made or how brushes are made or how canvases are stretched or any of that stuff. I'm going to buy the canvas. It's already going to be gessoed. I'm just going to put paint on it. That's totally fine. And that's true in this realm too. So very frequently, and if you see me work, you've seen me do this a lot. When it's time to do something, especially if it's a complicated low-level task, I will very frequently find a library. A library is just like a set of, well, it's like a library. It's a library of pieces of code, kind of, or functions that somebody else has written. Like if I needed to do a very specific math operation or something like that, either I could write the code to do it, or I could use a library to do it. Or draw things on a screen or do musical things. Like, you've seen me do both of those things. Like, sometimes when I do musical things, I'll use some kind of library to do the music and sound stuff. Sometimes I'll want to be really low level and I'll like produce the sounds from waveforms. So also understand that there's like, that's kind of that high ceiling, but you don't have to go all the way to that ceiling. And it's also that deep depth, but you don't all have to go all the way to that depth. You can kind of operate in the middle somewhere if that's more comfortable for you. And on that subject, there's a huge range of software and hardware platforms and tools to build on. Like, it has never been easier. I think that's fair to say. It's just never been easier to do any kind of technology work. There are downsides to that, for sure. Like, you get invested in some sort of platform or tools that somebody else builds and they discontinue them, or they shut them down, or they change the prices, or the kind of way the world works changes and that old technology doesn't work as well. So there can be downsides to letting other people do the job for you. But I think in many cases, it saves a lot of time and effort if you are open to that, especially when you're starting out. I think when you're beginning, I think that's okay. Next is, if there are sort of two kind of mindsets that are essential, it's not about being good at math. It's not about being good at art. It's not about those things. It's really so much of what it comes down to, other than just coming up with the concepts, is kind of the tinkering and problem solving. Those are just essential. In fact, I kind of want to break this out into its own section because I think this is so... Let's call this the learning process, because I think it's so much of this stuff barely works, or is barely documented, or is like open source projects, or came out of a school or something. And it's just, it's pretty essential that you have the willingness to mess with it. And when it doesn't work, that you have the willingness to solve some problems and go search around on the internet. Like, again, if you've ever watched me work, I rarely go 10 or 15 minutes working without going and looking something up. Like, I just do. And while I'm not a person that posts on message boards and forums and things like that, I rely on those people. So definitely don't be shy if you have a question. There's so many online resources to post questions at all different skill levels. And you might be surprised at how willing people are to help you as long as you kind of follow the rules of those places. So I think that tinkering and problem solving are really essential. And then if I was going to say, this is kind of a broad thing on how I think you should, what I think is the best way to learn any creative endeavor, I think personally, or it's just one way to do it at least, is this process of imitation to emulation to creation. Let's spell, wait, how do you spell imitation? 1M, okay. And what I mean by that is, obviously, once you're established in your career, you don't want to plagiarize. You don't want to steal other people's ideas. You just don't want to do that. There's a million reasons you don't want to do that. There's sometimes when it's acceptable if it's clearly a tribute or an homage, but generally, when you're established and you know what you're doing, you should be creating your own work. Now, when you're just learning, I don't think that's true. I will say, I think personally, one of the best ways to start learning, especially in a creative realm, is imitation. And I mean that on kind of a lot of levels. So one level is, imagine you're gonna play guitar. You know, there's two components of playing a guitar, really. There's just the mechanical aspect of strumming and moving your fingers. There's nothing musical about that. That's mechanical, and that takes practice and it takes learning. And that's really separate from the conceptual part. You know, in fact, I'm going to write these down. It's because there's sort of the mechanical part, there's the conceptual part, and there is the creative part. And so, for example, in music, if you want to think of what those three pieces mean, the mechanical part is just like putting your hands on the piano and understanding how to move your fingers, or on the guitar, or on whatever the instrument is. That takes practice. You've got to learn how to do that. Separately from that is sort of the concept of how these things work. Like, okay, in the case of a guitar, like music theory, what is a chord? How do these individual notes come together? What is a scale? Like, what are these intervals? How does that stuff work? That's separate from the mechanical. You could sit all day and with a piece of paper and work on music theory. That's not the same as playing the music. And I will say both of those things, while they're critical, the mechanical, meaning you can do the thing, the conceptual, meaning you know how the thing works, that's still separate from the creative act. Like, you could be the most mechanically proficient pianist in the world, meaning you just have the dexterity to use that device better than anybody else. You could have the highest degree of conceptual music theory, like how all of these notes work, how they all interplay together, how the frequencies work in the instrument to create the sounds. Like, right? You can understand the ideas of all of that, and you still aren't making music yet. You're still not writing music. You still haven't gotten to the creative endeavor. So these all are things you have to learn and practice. And I will say, I think it's really difficult to learn and practice all three at the same time. I think it's almost a little foolhardy to think that you're going to do all three of those things. Maybe if you're in college and it's a structured program. But I think most people, they sit down and they say, I'm going to learn how to play guitar. And maybe they do a little bit of conceptual to understand, like, what are chords, what do the chords mean, and a whole lot of mechanical. And then the first thing they're going to do is imitate somebody. I think I know that's not the way everybody learns, but I think it's so common, is the first thing you're going to do with the guitar is be like, okay, now I'm going to play this song by the Beatles or Elliott Smith or anybody, Radiohead, The Strokes, whatever. It's somebody that you're like, I really love this song and I want to learn how to play this song. You are practicing the mechanical. To some degree, you're practicing the conceptual if you're reading tablature or sheet music for it. You're practicing both of these things just in the imitation. Even if you don't bring anything new into the world, you still are, because it's your version of it. But even if you're just playing Blackbird by the Beatles and it's purely imitating them, you're still learning this stuff. Now, the creative is another issue, and in fact, I will say one more thing on imitation. I think the same applies for art and drawing. Is that a great way to learn to draw, especially if you're interested in illustration or cartooning, is to draw other people's characters. Is to just, I don't know how many stories I've heard of people that who become successful illustrators, designers, visual artists later in life who started out by just copying from a comic book or a cartoon or whatever. And I think that's great, because also with drawing, you have the same issues of the mechanical and the conceptual being separate from the creative. You have to mechanically know how to apply that medium, whether it's charcoal or pencil or wax or whatever, apply that to the paper. And that's different than the conceptual. The conceptual might be like, oh, there's some color theory here, and there's some issues of value and contrast and composition. And those are all important things, but you're still not necessarily creating anything new while you're working in this realm. And I don't want to disparage people who are in these purely mechanical, purely conceptual realms, but what we're talking about today is creative work. And it takes this stuff to some degree before you get here. So the next step, I would say, and it's kind of the simplified process, is emulation. So no longer am I just going to pick up my guitar and play Blackbird by the Beatles or whatever I'm going to play. I'm going to play a song that I wrote, and actually I think this very often happens accidentally as you're learning. I'm going to play a song that is my song and I wrote it, right? But it's probably going to sound like a Beatles song if that's all I play. Just because those are the chords I know, those are the intervals I know, those are the rhythms I know and music delivery I know. So emulation is kind of I think people often do this accidentally, where they accidentally are aping the things they like. And I believe, I can never find the reference for this, but I'm almost positive in undergrad art classes, I read about this being kind of a path at a Renaissance workshop. Meaning, like, you'd have the master at the workshop, and that master would say, okay, this border is going to look like this. You do this exact thing all the way around, right? And then maybe next, the master is sort of like, okay, you know how I make borders. This is a made up example, but hopefully you understand the point. You know how I make borders, you make your version of the border. And then finally, that person will move on, hopefully, and learn to create their own thing and have their own style and their own aesthetic and their own voice. But I think this is a useful process. So why am I talking about this? Because I also think this is useful in this creative technology, these kind of technology-based arts. I think it's great to start with imitation. And in fact, you'll see me very frequently just straight up cut and paste blocks of code just to do some trivial thing that aren't. And no, I don't consider that plagiarism. I consider that like standing on the shoulders of giants. Like somebody made some like whatever math routine, some math function that I don't want to have to piece out myself, and so I'll just copy it and paste it. Because it's again, like talking about the huge range of software and hardware platforms and tools to build on, I personally find the more you can build on existing foundations, particularly with like low level and frankly like slightly tedious technology things, the more I enjoy the process. So I think imitation can start by just looking at projects that I work on or Dan Schiffen works on or anybody who's in like the creative tech world, and just say like, well, I want to make that thing. And I frequently have people from schools or libraries write me about my projects and ask like, oh, we want to do a workshop where we make that thing. And I'm pretty open to it because I would be pretty upset if some artist just totally copied something I made and released it as their own. But for someone who's learning, a student at school or in a workshop or something like that, I think it's a good way to learn. So I don't have a problem with that. Similarly with emulation. So for example, I've had a number of people imitate the beatbox, just saying like, how do you build this thing? We want to do a workshop at our library. And I think that's great. And then emulation has been like, okay, we did that, but we made it a little different. We made it with pears or whatever, like we made it with something else. We made it with turnips so we could turn up the beat. And then, creation would be like, well, now we're going to make our own thing with capacitive touch. So that was kind of rambling, but I hope that gives you an idea of what your learning process can be here, because I don't think it is really that different from other creative endeavors. So having said all of those things, like what are the actual pieces of this? When we talk about creative technology, like what does that actually mean? It kind of doesn't mean anything. It sort of means like you're making art and somewhere in the process electricity is involved. Like that's it's so broad. It's so very broad what it can mean. But you're basically leveraging some form of technology. I won't even say modern or contemporary because it could be some kind of primitive technology, I think, and still count in this realm, to facilitate your creative work, your creative expression. What it often involves for me personally, the three pieces that I find myself focusing on the most is creative software development, which we're going to talk more in length, and that is programming. It's not always programming in the sense of writing code. There are like node-based things where you're just connecting dots, but you're using logic on a computer to create the thing that you want to create, whatever the actual steps you take are. And that can be very, very low level, kind of like we talked about above, where you're making your own paintbrush, you're like at the lowest level writing your own software, or it can be very high level, where you're using some existing tool or platform, and you don't have to work very hard to do the job that you want to do. As an example that I've heard other people complain about, I think I heard Jonathan Blow complain about this. It is surprisingly hard to just draw a circle on a screen. If you're a person and you want to tell a computer, and I don't mean open Photoshop and use their tools to do it. I mean, if I'm just a person that's like, okay, I know that computers follow instructions. I want to give the computer some instructions to draw a circle on a screen. If you do that at the lowest level possible, it's a real hassle. It is very tedious. It's very complicated. And there's lots of middle kind of, what would you call that? Like languages that are sort of, you can go kind of close to bare metal. You're writing the computer instructions. You can go up to these sort of low level or high level languages, or you can do these things that kind of even sit on top of high level languages that make it much easier. And that's kind of similar with the hardware development. So you again can go as low as you want. You can get a pile of resistors and capacitors and diodes and whatever other simple analog circuitry that we've had for decades, transistors. And you can put those together and you can build a circuit to do almost anything you want. It will probably be really complicated though if you want to do something complicated. You can also use a kind of higher level. There's lots of little chips, little digital chips that serve certain purposes and accomplish certain goals in a very tiny package. So, you might have a circuit that would take up this much room on a circuit board if you made it yourself. But wait, sorry, I'm gonna close that because it's distracting. You could very likely find some kind of chip that could do that same amount of work in a tiny little package. Who's clicking on my screen? Was that Draclin? I'm being clicked. So that's our new heat thing that we did. We'll talk about that someday. So again, huge range of complexity here. You can start all the way down with bare components and wire and electricity and make whatever you want, or you can use tools to do, these existing chips, these existing platforms that you can build on top of. I made that one on Tuesday after the last chat. Yes, bare components, bare arms. So, and then in addition to the hardware development, in addition to the software development, like I'm making a computer do something, or I'm kind of making my own hardware that's going to do something. There's this issue that comes up in basically every project I work on is how do you make this stuff talk? How does the hardware talk to the software? How do two pieces of software in different buildings talk to each other? And we won't go deeply into that, but it's a big enough topic that, there's a Tom Igoe book, in fact, that's called Making Things Talk, that is kind of about this. He's very much kind of a physical computing person. This book may be a little outdated now, I don't actually know. But it's kind of about that. It's about like, how are we gonna make things talk? And he's focused very much on hardware and sensors and networks to make things communicate. Because it's a big topic. And I will say, I have definitely done projects where 90% of my work on the project was not up here. It wasn't about this. It was me saying like, well, what if I took these interesting things that already exist and I figured out how to make them talk? That sometimes can be the most interesting part of a project, but it's also a little hard to explain because it means different things in different contexts. But it can be a major part of the creative process for sure. It's just like if I could just get information from here to here, I could do something really interesting without a lot of work. So moving into the software part of that. Broadly, what I mean when we talk about the software development, again, this is writing code or using tools to create computer instructions. Talk can mean a lot of things. Like it's getting a signal from one place to another is maybe the simplest point. So yeah, it could be TCP/IP, it could be like complicated networking, or it could be like I have a beat right here, and I want my computer to know when I touch that beat, and what hardware and software has to go in the middle. Or I have, like we've been doing on stream, I have a phone in my hand right here, and I want the movement of this phone to appear on this computer over here. Like whatever it takes to do that. I know, the Beats by Scott, I blew it. I missed a marketing opportunity. So very often what we're talking about when we're talking about this creative software development, we're writing code, or again, maybe we're plugging in together modules. It doesn't necessarily have to be writing code. To draw images or create sounds or more. So very often, not always, but very often, these are still arts projects in these realms, in these kind of traditional realms that you think of. Like in the realm of visual art, you might draw something on a screen using software. You might create sounds or music using software. And you've seen me do projects like this. But it doesn't just have to be that. You could do things that has nothing to do with visual art or sound. You could make a smell-based artwork with kind of like some sort of aerosol that would spray things in your face. Like it doesn't have to just be sight and sound. You're creating the work that you create. I think in this realm of software, you have to, in fact, I'm going to move this up because I think this is the next thing I want to talk about. Because with what I just said, okay, we're writing code, we're creating programs that do these things. But I think a really important thing to understand that a lot of people don't understand is that programming isn't just about knowing one programming language or another. Just like human speech isn't about a language. Like, I can say the exact same thing that I'm saying if I knew these other languages in 20 different languages. Like, the language is just a way to deliver those concepts. It's the concepts that matter. The language syntax and constructs are just how you deliver that to the computer. So, you know, you hear people get hung up on things like knowing C or knowing C++ or C# or knowing JavaScript or knowing Python or knowing Java. And it's surprisingly, people who understand computer programming, I hear say things like that. Like, oh, I know this language, but I don't know that language. I don't think it's, the language part to me is the least important. There are things that it is useful to know about different languages, especially if you want to write really performant, efficient code. But for someone who's starting out and just wants to accomplish the basic things that they want to accomplish, the language really doesn't matter that much. And I will say, you know, some huge percentage of my code, I don't really have a number to put on it, looks exactly the same regardless of the language I put it in. Especially because so many languages are derived from C, and because I have a certain programming style, if you looked at something that I wrote in C# versus C versus JavaScript versus Java versus any of these languages that are derived from C, they're gonna look the same for the most part. They're gonna have a bunch of curly brackets, they're gonna have a bunch of ifs, they're gonna have a bunch of indents, less thans, parentheses, greater thans, like it's gonna kind of look the same. So don't worry too much when you're first starting out about what language you're learning or what language you're gonna learn, because it's a little bit irrelevant. Like, I've kind of settled down into 2 or 3 languages that I use most frequently. In fact, probably 2 at this point. I most frequently use C# and JavaScript, but like, it would not be the end of the world if for whatever reason I had to sit down and write some Python. Or some Java or whatever. It might take me a minute to remember how to do it, and I would definitely be looking up things a lot. Especially if I had to like write a pure C program, just because I haven't worried about allocating memory in a while. Like, there's concepts that of course are language and implementation specific, like the language you're writing in and where you're writing it. But what makes you a good programmer isn't that, I believe. So don't get too hung up on that. As far as places to start as a beginner with software, I think processing and P5.js are great for that. In fact, processing in particular was kind of invented for that. And you've seen me, I don't know if you've seen me use processing. You probably have. You've certainly seen me use P5. But the idea of processing was, well, it came out of MIT, which kind of a precursor to it was something called Design by Numbers by John Maeda. And then Ben Fry and Casey Reese created processing, I think, as their doctoral thesis at MIT. But the idea was basically, and these are my words, is that programmers should be able to create art and artists should be able to program. And it shouldn't be that hard mechanically for either of them to do those jobs. That's not that it's going to make you a good artist or make you a good programmer, but you should be able to just at least do the thing you want to do. And so, like what I said before about it being hard to draw on a screen.
Hello, my name is Dan Schiffman.
This is Dan, he's amazing. In fact, you should be watching Dan right now instead of me. So this is Dan talking about processing. But at the end of the day, it's a standalone program that you run, but it's also kind of a language that is based on, that's built on Java, but it's simplified and has a lot of convenient things for you. But if you want to draw a circle in processing, it's dramatically easier. Now, you do have to know that a circle is called an ellipse. In fact, no, you can draw a circle. So if you want to draw a circle, it doesn't take much more code than this. You say you want a circle, you say where you want it on the screen, and you say how big it is. And that's kind of all you need. And then you have way more you can do from that. But the fundamentals of it are very accessible. And processing has a lot of tutorials and tools and examples on how to do this stuff. Dan Schiffman himself has like amazing videos on how to get started with it. So I'm a huge proponent of processing, even though I don't personally use it very much anymore. I do use P5, which is kind of an extension of processing that works in the web browser. And one of the reasons I love it is then all you need is a web browser. And if you have a web browser, you can do interesting things with P5. And you can, once again, if you want to draw a circle, you can draw a circle and it's pretty silly. You might actually have to say ellipse. Nope, you can still say circle. So you can say circle in a web browser with a little bit of setup, not very much setup at all. And that's all it takes. So I'm a big fan of these if you want to start just understanding what programming is, because there's so much support and good community around it, and they're good tools. Like, you can make good things with these. Alternate path, and the thing I probably use more than anything else, is Unity. And I love Unity because it is kind of an environment that does a whole lot of things that I find useful all in one place. In a way that Flash, years ago, Flash used to do this. It was a place you could kind of draw, and Flash was a place you could draw and animate and do traditional animation and write code, and that world is no longer with us, but Unity does most of those things. Like, I generally create assets outside of Unity, but all of the like positioning and animating, so much of that stuff you can do in it. And it is free if you just want to get it and start playing with it, and very accessible, lots of good tutorials. But it will also take you far. So one of the downsides of processing is you would probably never go into the world and go to a AAA game studio or even an indie game studio and decide like, okay, we're going to make a game in processing. You just wouldn't. It's not quite the right tool for that. But there's plenty of big, amazing, beautiful games made in Unity. The biggest of the big games probably have custom, essentially kind of their own in-house custom versions of something like Unity. But it is a very useful skill to have, to know how to use this software. And again, going back to the very top of our discussion, that doesn't mean you have to be a programmer. You can use Unity without writing a line of code, because there's so much other work to be done in terms of assets and animation and lighting and textures and all of those things that are important parts of the process that aren't just programming. And I've definitely known people that have done interesting things in Unity that had really pretty minimal programming skills. And Unity, in addition to, letting you write whatever you want in C#, there's also tools like Bolt and Playmaker that are visual scripting, where if you're more comfortable with a visual way of giving a computer instructions, you can do that. And of course, that is the tip of the iceberg. Those are the things that Unity is the tool that I use most. Processing and P5 are the tools that I recommend most, but there is a infinite number of these kinds of things. There's other tools that are designed to be simple ways to draw things on screen. Maybe they're a little more complicated, but then maybe they're a little more powerful. 3JS is something, for example, that I use very often to do 3D work in a web browser, but you got to kind of have some programming proficiency to use it. There are other game engines. Hello, how's it going? Oh my gosh, that is too long of a name. How about can I give initials? Oh yes, your name. I'm shocked by your name. Okay, I won't mind it. Yeah, that's a great point. In addition, C# is relatively easy to wrap your head around versus lower level versions of C, where you're worried about allocating memory and things like that. C#, .NET, that weird combo that sometimes it's hard to know where to draw the line between them. So much is done for you in terms of some of those more complicated low-level things. And yeah, there are amazing resources, lots of forums and Discords and various other places that you can learn. So I'm a huge proponent of Unity. I really like it a lot. But if there's something else you want to learn, you should learn it, because there's tons of other tools. Talking similarly about hardware in that realm is, I need to give you a nickname that isn't quite so weird. Wash? I could just call you Wash. Okay, in the realm of creative hardware development. So we talked about software. Now, hardware, and this is one that people tend to find more daunting. And it's understandable because suddenly it's like, oh, there's a tangible thing in front of me. This isn't just me typing into a computer. I have like a device in front of me. And there's lots of things you can do with custom hardware, of course. Like you could design hardware to do anything. Like anything that you've ever seen a computer or electronics device can do. Of course, given time and money and effort, you could make that thing. But generally, in the world of creative technology, this is mainly what I'm doing. I'm mainly doing these three things. I'm using sensors, indicators, and actuators to interface with the outside world. That's mainly what it is. So I'm using sensors to like understand the world. And those sensors, like in the phone, can tell me the orientation of the phone. This phone also has an ambient light sensor, and it can tell me how bright the light is. There's sensors for temperature and humidity and alcohol gas and vibration. There's sensors for so many things. And to me, one of the most interesting things about the world of physical computing, which is another name for like creative hardware development, is it's just limitless. If we go to SparkFun, they sell a lot of sensors like this, and just look at so this is an IR rangefinder. So this is a sensor that can tell you how far something is away using infrared light. This is a GPS dead reckoning breakout. So this uses a GPS to try to understand where something is moving through space. GPS meaning Satellite Global Positioning System. I don't even know what some of these things are. Here's a humidity detector. I didn't even know what would be here. Just looking at some of the things on the page. So those are examples of sensors. Indicators, and this is kind of my word for this. Indicators are ways, so sensors tell the hardware, software land, tell it about the world. Indicators are ways that you can tell the world something. So like, if I had a light that flashed on my phone when I got a text message or something like that, or like, I don't know, these examples are a little weird. I mean, even just the light that something's on, like on this Xbox controller right here has a light on the front that is indicating to me that it is on. Like that's kind of an indicator. And so LEDs, things like that are good indicators. They just are a way to indicate something is going on. Or screens. Screens are maybe the most common form of indicator. It's a way for hardware and software to tell you what's up. Actuators, so sensors are input, indicators and actuators are output. Actuators are actually about changing the world. So not just telling you something, not just showing you a light or showing you something on the screen. And these are my distinctions again. Actuators are about, let's turn this motor and raise this flag, or open this window, or let's use this solenoid to hit this pool ball and have it roll away, or I mean, any number, turn on this fan to blow this balloon around, whatever it is. There's all kinds of actuators. In fact, there's probably, maybe if we looked in the robotics section, we would find more actuators. Yeah, these like wheels and motors and servos and a vacuum pump and solenoids. And these are ways that you can use to physically change the world around you. And which is pretty cool. Like you can build systems that have an effect on the world in whatever small way. As far as how to build these things, to me the gold standard, and there's just kind of no comparison, is Arduino. Almost anything I do that has some kind of custom hardware has an Arduino in it, or some clone or variant of an Arduino. And to me, like, what processing is to the software world, Arduino is to the hardware world. Not only is it incredibly flexible, incredibly powerful, and very inexpensive, it is also it's well supported and easy to learn. There's lots of tutorials, there's lots of documentation, there's lots of things to get you started. So just like what I was saying before with software and using, maybe use P5 or processing as a way to get started and learn, Arduino is amazing for that. But the difference is, whereas, I kind of said there was maybe a ceiling of how far you'd want to go with processing, and I should qualify that saying, I've seen people make amazing things with processing, but I do feel like there's a certain point where you'd want to either start building custom software, or using a lower level framework like Open Frameworks or something, or using a game engine like Unity. But Arduino almost doesn't have a ceiling. Like, yes, there's probably a point where you just want to design your own totally custom hardware. But even when I design custom circuits, in the middle of that custom circuit, you will often find an Arduino because it is so good at these things, at these three things like Arduino excels at that kind of input and output. And it's very learnable and it's very manageable. It's very inexpensive. It's also very reliable. So much of the work that I do within Children's Museum, I mean, again, it's probably almost true that everything I've made for the Children's Museum has an Arduino or something very similar to an Arduino in it. And if you're not familiar with what an Arduino is, it's a little, that's not what I want at all. It's a piece of hardware that it doesn't have to, but can connect to your computer via USB, just like any other USB device. You know what? How about an Arduino? I feel like that's the canonical. Yeah, so this is a USB port that'll let you plug it into the computer. It could also be powered independently and not even need a computer. This is a specialized chip. It's a microcontroller that can do a lot of different things. It's not general purpose like the processor in your computer or laptop or phone. It's more specialized than that, but it's still very flexible. And basically what you do is you write some code to, usually, you don't have to, there's ways around it, to tell this kind of little microcontroller what to do. And then it uses all of these pins to talk to the sensors and indicators and actuators. And either it can do everything, you could have lights and motors hooked to this and sensors, and it could exist, plug in some power, and it can exist and run all by itself. Or, and what I more frequently do, is it can talk to your computer and tell you what's up over this USB port. So very frequently I have something like a computer and something like an Arduino in many of the projects I do that involve custom hardware. Now, the learning curve here is maybe a bit steeper than with processing, although there are things like Fermata that can make it even easier to use processing with Arduino. Processing and Arduino pair really nicely. And in fact, my undergrad program at NYU, the Interactive Telecommunications program, kind of the core foundation of that entire graduate program was learning about the Arduino and learning about processing. Most students took those classes. I was already pretty into it, so I didn't, but most students start out by taking classes to learn about processing and learning about Arduino, and that's the foundation of their understanding for all of programming and all of hardware development. And just to show you, because maybe it's a little difficult to imagine how that thing gets used, very often it's used for this, which is usually called maybe like breadboard prototyping, where you have your Arduino and you're gonna run some wires from your Arduino to this, it's called a breadboard, where you can just stick in components and electronics components and build a circuit. And then your Arduino can talk to it and control it. And it looks a little spaghetti-ish and messy, but that's kind of how prototypes look sometimes. But so an important point there is you don't even have to be able to solder to do this kind of prototyping and this kind of experimenting. Like, it looks like this. I don't know what this does, but if I had to guess what this does, I would guess if you push this button, this light turns on. And that's all it is. It's a button, it's a light, and it's one resistor. There's a couple of cables that are bringing over power. There's some cables that are talking to the button. There's some cables that are talking to the LED. And that's all it is. It can be very, very simple, or it can be enormously complicated. Let's see, maybe we can find it in a custom PCB, where you might build something like this, where you build your own custom PCB, where you just kind of stick an Arduino right in the middle of it. So this is a preamp somebody made by they've got an Arduino that's just dropped right in the middle of that circuit. It looks like these are where the vacuum tubes go, if I had to guess. Or this cool little LED cube has a place where they just crammed in an Arduino Uno, it looks like. These are maybe, I don't know, shift registers or LED drivers, I don't exactly know. Some kind of customized chip. So there's a huge range of stuff you can do. And so sometimes I'm doing this kind of thing. In fact, very frequently, just prototyping, testing on a breadboard, no soldering, just plugging in wires. It brings me back to my old days of like these old school Radio Shack Radio Shack electronics kits I had when I was a kid. Like this kind of thing where you just stick a bunch of wires together. It was kind of like this, but way more flexible. And then sometimes I'm doing like custom PCB design. Not as often, and honestly, I'm kind of out of practice on that, but I've started doing it again. Where you're getting into some PCB design software and you're designing a custom circuit board. That's the CB. You're designing your own custom circuit board. So that's another place where there's like a very low barrier to entry, but the ceiling is very high and the depth of possibility is very deep. So, what is this software? Proteus. I've never used Proteus. I am frankly a novice, maybe intermediate at best at PCB design. Definitely not a realm of expertise for me. So that's even me after years of doing this. There's certainly things that are like not very easily within my wheelhouse. Like, but I like that. I like projects having new levels of challenge and difficulty. So that's another thing to keep in mind. You know, yes, you could end up here someday. You could end up where you're designing these custom PCBs. One, I will say it's not quite as hard as it looks. Like it looks really complicated, but it's actually kind of fun to make these. Maybe we'll do that on stream someday. But you can also be in this realm where you've got a few very simple components that you're sticking in a breadboard, and it's like, it's anybody can do it. Anybody can do it. And the worst thing that could happen here is maybe you forget the resistor and you burn out your LED, or you put your LED in backwards and it doesn't work. Like, it's fine. LEDs are very replaceable. So yeah, I love that. Now, you've probably heard of a Raspberry Pi, and there are things I really like about it. But to me, the thing it is sold as is honestly, to me, a little disingenuous. And I don't think it's that they're being deceitful. I think they're just kind of wrong. Like, Raspberry Pi is sort of sold as, yeah, it was created by the Raspberry Pi Foundation to promote the teaching of basic computer science in schools in developing countries. I frankly don't think it's very good at that, because it's still, at the end of the day, it's a computer that runs Linux, and Linux is just not friendly. Like, I've been using Linux for 23 or 24 years, and I think Linux is amazing, and the whole world runs on Linux. Like, all, you know, most of the servers in the world that are running the internet are running on Linux, but on the desktop, it's finicky and it's a hassle. You may enjoy that though. I mean, so I will say, when I was much younger, I really enjoyed just tinkering with electronics, and I didn't care very much about what I did with them. And so you may totally enjoy that. And there are plenty of people that do, that just want to tinker. But if you want to make something happen, if you want to create something and make something happen, a Raspberry Pi is a pretty finicky tool. And let me just tell you what's really good about it is one of the things that's really good about it. Where's a recent one? This is the 3. This is new enough. Is that it is almost, this Broadcom chip, it's almost like a cell phone, just without a screen or a case. That's almost what it is. That's almost how powerful it is. Almost. It's not really nearly as powerful as like a high-end cell phone, but it's almost like a tiny computer. Just like this is a tiny computer, it's a tiny computer that you have way more flexibility in telling it what to do. So it can do the things your laptop or desktop computer can do, but it's the size of a credit card, which is pretty cool. It's just kind of finicky to get it to do those things. And I will also say that these pens right here are called GPIO pens. And using these pens, you can also do a lot of things that an Arduino can do. So in some of my projects, instead of using an Arduino in the past, I've hooked those sensors, those indicators, those actuators directly up to a Raspberry Pi. I almost never do that anymore, because it's frankly just a little bit of a hassle. I frankly just don't really like it. I much prefer, even when I do use a Raspberry Pi, which is relatively frequent because they're very tiny, I'm trying to think of a good picture to show you. I mean, even if we go back to Reach, and look at my first project with the museum, you'll see a whole bunch of Arduinos And then this is a Beagle board, which is basically a Raspberry Pi. So even though I still probably could have talked to all the sensors and circuitry directly from, directly from the computer, the Raspberry Pi-ish device here, I found it more straightforward to do this because one thing that I'm a big proponent for in these complicated interactive creative technology experiences is clear modules. Like I want one thing to do a certain job, so if something breaks, I know what broke, rather than like one big machine that does every single thing. So for example, these are the machines whose job it was to detect the touch, and I had multiples of those. And then this was the machine whose job it was to get that information and do something with it. So that's a working style that I prefer. And one, I also just find it way easier to work on this PC or that Mac laptop where I can just plug an Arduino in and work in the environments that I'm comfortable in working, put the code on the Arduino and have the Arduino talk to me. When you're dealing with GPIO pins, you kind of have to be working on a Raspberry Pi. There's sort of no way around it. And I just don't prefer to do my work on a Raspberry Pi. There's a million ways I could set it up where I was like on this machine and remotely connected to it, but I just find it a little easier. And you do save a little money, but these are not expensive devices. You know, like something like an Arduino, this is, I think is a Nano or an Uno, those are all around $20. And Raspberry Pis, depending on what you get, start at around $35. So they're not tremendously expensive devices. So I don't often develop on a Raspberry Pi or use it for direct hardware communication. And the main reason I use a Raspberry Pi is that it's very inexpensive. So if I'm sending something out into the world or if something just has to live somewhere, rather than buying a $700 or $800 computer, or even $400 computer, I buy a $35 computer. And that's way nicer. You know, it's way less expensive. It's easier to replace. I don't have to worry about it. They're very robust. They're reliable. They're just harder to work on. There's a cost. Like that miniaturization, scaling a project down so it runs on the device is not super straightforward. So I just wanted to throw that in as saying like, they're pretty interesting devices. I use them. I think there's definitely a place for them, but I would not say, if I was going to say, oh, today I'm going to get started in creative technology, I would not start with the Raspberry Pi. If you want to tinker with the Raspberry Pi, you certainly should, because they're interesting devices and they can be fun. But I think I worry that it would be a frustrating place to start. I think Arduino plus processing is where I would start. And then, of course, in addition to this, using the stuff like all those things we looked at and we saw at SparkFun, all these things you can just buy that do some of the work, even the Arduino that you can just buy that does some of the work. You can also just build all that stuff by yourself. Oh, thank you so much for hanging out. I didn't even realize you were there. Did I go for too long? Oh my gosh, I went for a whole hour again. Okay, I will see you next time. We're basically gonna finish. We're basically finished. Yeah, so you can build your own custom surfaces, circuits. And finally, just as like to end this with where to start, I will say there are tons of kits and ecosystems and tools, and lots of people have beginner kits you can buy and whatever, but for my money, processing on Arduino is the place to start. And so that is processing.org. I think is an amazing place to start, and arduino.cc. If you just start in those two places, processing for software and Arduino for hardware, I think that's the place. I think that's the place you want to be, personally. Other people might tell you other things. That's kind of, and the Arduino is if you're interested in the hardware part. You can certainly do creative technology projects that have no hardware. For the last many years, 4 or 5 years, I was primarily focused on AR and VR projects and wasn't actually dealing with much custom hardware. The hardware I was dealing with was off the shelf, like an Oculus Rift or a cell phone. I'm kind of recording a video right now. I'm doing a residency with the Children's Museum of Pittsburgh, and so as part of that residency, twice weekly, I'm doing kind of workshop-y streams like this that I'm doing live while talking, but then yes, they will also go on to they'll go onto YouTube after the fact. So I'm trying to wrap that up, and then maybe we'll just work on like a weird project for the rest of the video, just so I don't steal more than an hour from everybody else. Thank you for hanging out, though. Is it okay if I call you Wash? Is that an acceptable acceptable title. So just to finish it off, there are plenty of processing tutorials and Arduino tutorials, but really, especially if you're a young person or if you're a parent that has kids that want to learn, Dan Schiffman has been a crucial figure in the processing community for years and years and years. In fact, some of his early projects were part of what inspired me to get into creative technology. So he has a kind of kids show-ish. He's got a book called Learning Processing. Oops, where did I just go? That can be useful if you're the kind of person who learns better from books. Okay, I'll call you Wash. He's got a show called The Coding Train, and it is adorable and it's ridiculous. And he covers all kinds of interesting sort of technology kinds of things. He has beginner videos and tutorials, but he also has complicated tutorials like machine learning tutorials and advanced P5.js. So I think he's awesome, and I highly recommend checking out all Dan Schiffman's work. He's a true gem. In fact, I kind of feel like we should just watch the intro to The Coding Train, because just the intro is like, okay, I want to watch the intro of The Coding Train. I think he shows it at the beginning of every episode. Oh no, where's the intro? Because it is absurd and amazing, and I love it. Yes, this. I love this. No, not this advertisement. I don't want the advertisement. Okay. Coding Train.
Let's find something we want to make, some crazy idea.
That's Dan.
We'll figure out what it takes to make that dream appear. We'll try to understand now as we ride along the Dan. Now hop on the coding train.
Pretty good jam.
Coding train. Come along and join us as we light it up in code, using only our imagination as the road. Whatever you're conceiving,
jealous
you'll start seeing what you're believing.
that Dan has this
Coding train.
I love it.
Coding train. Pick you all up at the station. We'll make things of our own creation. Fireworks. We can generate sounds or trees or mazes. Make a butterfly or reflect our faces. A retro game for a Twitter vibe. And never forget that this time just hop on the coding train. Coding train. Coding train.
I'm probably gonna get flagged now. I'm probably gonna get flagged for monetization when I upload this to YouTube. That happens to me. I accidentally I will do a 3-hour video and play 15 seconds of some song, and then suddenly some other person is monetizing the video. Okay, we're gonna call this video finished. I mean the proper part of this. So the actual residency workshop-y presentation part is done. That was a really high-level overview. I would be very glad to answer questions, and we can, over time, we maybe dive into deeper parts of this. At some point, though, we really need to work on the residency project itself. I'm going to take a very short break, and I will be back in a few minutes, and then maybe we'll, I don't know what we'll do. We'll make something. We'll make some kind of something. Maybe we'll play with heat a little bit more. I'll be back very shortly. Hello, it's me, I'm back. It's me, still Scott. Let's just, okay, what were we doing? Where's Jacqueline? He's probably working again. And Life is Yours is taking a test today? Very serious stuff. So, after the stream, whatever, this is our post-stream. This is our post-stream stream? Post-workshop stream? I don't know. Last time, we made a new heat thing. What do we call it? What are those called? Heat visualization? So that should be active, actually. So anybody watching, if you click on my video, if you're in the using the desktop viewer, excuse me, you should be able to spawn strange little particles. This is definitely an emulation imitation thing. In fact, this is kind of an imitation. This is an imitation of something that Scott Murray made. But I think he was emulating someone too. I think it was from the Processing Banner. I'm not sure who the original author is. Could have been Ben Fry or Casey Reese. Hard to say. Yeah, so as you click around, we're just spawning little points, and then those points, based on proximity, get connected to each other. And that's actually what kind of works okay. The thing I don't like about it, though, is that things are just popping off. Like, as we click around, I don't like the pop. So the connective tissue, those will probably kind of always pop, but I don't mind that as much. It's like as things get close, they connect to each other. We could animate that, it'd be a little annoying. But I don't mind that. But if we were going to change something, I think it would be my eyeballs. That looked like my eyeballs popped out of my head. Oops, I double clicked. So when I first wrote this, Twitch didn't make the video big when you double clicked, and then they added that when you had an extension running. So it's kind of annoying. If you accidentally double click while using heat, it does the thing. Okay, we called this Heat Connect. So we have that here. And we just did this on Glitch. I was transforming spherical message meshes in Unity. What was I doing with that? What was I doing to them? Was I doing like extrusions and making them extrude and pulsate? I don't know. I do a lot of things. Yeah, so that was... Some of that ended up going into a project that I can't talk about yet because it's not released. So some of that work for real-time mesh deformation ended up going into... yeah, especially some of this stuff, like some of this procedural animation and the OFF import stuff. That stuff is in a project that will hopefully, it kind of got delayed because of COVID, which is very understandable. But that will eventually be in a project that's coming out. And then some of it, that was this stuff. Some of that other earlier pulsating, man, I don't know. That's procedural mesh generation. I know what was it this thing? I don't know. There's too many things that I make and I never know. Whoa. Oh yeah, I have a YouTube. Thanks, robot. I kind of forgot about that. Oh, but that says Jungle Arrow. I think I can use Scott Gardner now. I think they let me change it to be not the name I made up in high school, which is good. So I kind of forgot that bot made this used commands like that. New pep talk? Yeah, thanks. Okay, the robot works. I kind of forgot we did that. Anyway, there's a project dwelling in my mind that I still really want to do that is based on some of that weird mesh deformation work. And that is this VR experience where you reach into your heart and you just pull things out of yourself. And I still really want to do that, but I would really love it if somebody paid me money to do it. So I applied to do, I've been applying for it for like different residencies and grants and things like that, and so far have not gotten it. So it may just be that I have to do it on my own time. But right now, I have too many projects and we got to work on the residency project, which is going to be a whole thing. So we could look at that. We could look at the residency project. Kind of just want to stream for maybe like another 45 minutes or so. So how's this work? This is our code for that, our little clicky friend. And I can also do one of these and click directly in the window. So all that works. I think actually my resize, we didn't add a resize because we don't really care for the video, but so one idea would be able to give these, we know when they're born, right? So then we know their age. So based on their age, we could fade them out, right? But I don't know how to change the hue of a color, like a P5 color. So if we have a color, I know you can extract the hue, but if you just have a color and you're in HSB mode, put your color, set alpha. So if we have a color, we can set alpha. Is that true or false? That sounds true to me. Yeah, so we're already setting the alpha to 50%. So we would want to do something like well, we kind of want to continue if we do this, right? We don't want to draw something that's just been killed. Let's continue with our while loop. Okay, so then we want to get the age. So age is going to be how to go there in there. That's not welcome. So that's our 8-second max age. And we want to get age out of max age, and it will give us like a percentage of life. So this will be something like date now minus circle.birth divided by max age. And then we kind of want to do something like, well, not kind of, I think we just want to do it. So circle.set alpha age divided by 2. Is that going to do the thing? Are they going to fade over time, or is this just broken? I've broken it. Did I really break it, or just make it where it can't draw? I've really broken it. Because it's circle.color. Really? Is it because that's not actually a color? Very windy outside. P5 color is a color, though, right? Oh boy, ECS. Yeah, I haven't really gotten into it yet. I've done some experiments with it. I haven't had a reason to. This residency project, maybe this residency project will be the reason that I finally decide I have to, because I want to draw enough things that it would make sense. Maybe, but I feel like, I don't know. I feel like for what I'm gonna do, I'm just gonna do a bunch of maybe compute shader stuff and do it all on the GPU. Yeah, I haven't had a totally compelling reason to do it yet, and also it feels like things are still in flux enough that I don't really want to invest myself. Okay, well, this looks like I just did bad math. How are you liking ECS? Oh, I said this is out of 100. Right. And I also did it backwards. So they're fading in instead of fading out, which is actually kind of cool. So we need one minus age divided by 2 times 100. No. 1 minus, invert the age, and just times 50. So these should now fade out over 8 seconds. Yeah, that seems like it were to be valuable, like where there are like very complex systems that you need to control over time. Okay, that fades those out. It is kind of weird to not have the lines fade out though, but that's sort of weird because you kind of want to fade one end and not the other. What if we didn't do age instead? What if we did it to the radius? Oh, then they just shrink away. I don't know. Maybe it was better when they popped. Maybe I'm all wrong. How does it look? How do I refresh this? Here. Good? Is it bad? I don't know. I thought I liked it. I think maybe I don't like it. So if you didn't watch last time, but you did watch this time, and you watched the first part of this, this is P5.js. So this is the JavaScript extension of processing. It's really like a parallel project, like a sibling project almost. It's most of the core functionality and features of processing, but ported to JavaScript. And I'm using a platform called Glitch, which we've used in the past, which is a handy way to have front-end and back-end code all in one place that you don't have to worry about very much. I don't know. Maybe it's just more complicated than it needs to be. Maybe it was simpler before. I don't know. Also, my heart's not quite in it. I mean, I feel like I did the thing. But I feel like I should work on the Residency project. What should we actually do for another like half hour or so? We have this. We have our mobile dancer. Which presumably still works. I think, hopefully, I don't think anywhere in the process of anything we've done over the last few streams we broke any of the like basic functionality. I misspelled it. You know what I need to do is just put a QR code in the corner that I can just scan and go where I want to go. How about we do that? Because at some point we'll probably want to do that to like have real user identification, or not like still be all anonymous, but. This will not be working. What did I break? Mobile? What the heck? Oh, is it just starting up that whole time? I'm having trouble getting this loaded. Okay, well then let's do this. Let's do this. This is a silly thing to do, but... You can use it at home too. Wait. Is this actually it? Is this correct? It doesn't fit in the tiny code pin window. What am I gonna do? What? What? Oh, weird. Okay. Does this work? Is this the real deal? Oh, it's not loading. Seems worrisome. Seems like maybe I did break something. I didn't think we had done anything that would cause this to break. What could we have done? Also, where's like... Oh, that would be anything's wrong. This just glitch being broken? We had this problem at one point where I like killed everything and then the server wouldn't work anymore. Is this one of those times? What? Something happened. What could I have done? We haven't changed anything here. Right? I mean, the express stuff, it's kind of the only thing I could imagine that would be broken. That's lame. We definitely had, okay, we were just using glitch. So glitch is working. Somehow we have broken. So last time we did we tried to do our binary packets. That's been a few streams ago though. It was all working fine. According to this, the app status is okay. Did it just now load? Why would that be? You still load? What are you loading? Our plans and dreams may be compromised at the moment because it feels like there's some command line thing I don't know what to look for. What? What a heartbreaking story. So I feel like to fix this last time we had to we like deleted and rebuilt our setup. I want to know if this is just like a way I can like force rebuilding the environment or something. Well, no, don't go there. No, we're falling apart here. I want to go here. Take me. Can I not copy this? Copy. Thank you. Seems like glitch is busted. Well, that's lame. We were just using it. What was that other thing? Heat. Maybe I broke it. Maybe I broke glitch. Yeah, that's a bummer because like they just started charging money. You have no idea. I have no idea what's going on either. I'm trying to right now I'm temporarily using glitch as the back end for the stuff I'm working on, and it appears to be down, which normally wouldn't be that big of a deal, but they just started charging for their service. So it'd be sort of a bummer if, I mean, I didn't start paying, but I was definitely, I moved some things back to glitch. Oh man, speaking of that, heat, I finally, all my AWS credit is gone. So I'm in a dark place. when it comes to back-end web services. I've got to move. I think I need to move Heat off of AWS because I don't want to pay for it. But I don't know where to move it. Maybe Heroku? Yeah, that's oh boy, I don't want to deal with that right now. Okay, well, this is great because it seems like the things that I was going to work on today are now broken. So well, why does this work? It kind of doesn't work. So glitch.com seems like it's working, but glitch.me, which I think is what's embedded in this iframe, is busted. With glitch status. All systems are operational. Well, look, everything's... Oh, there was a little divot here. What does that mean? No incidents reported. What about the incident I'm having right now? I guess I could report it. Okay, well, cool. What are we gonna do instead? Let's instead, now that I've wasted 15 minutes trying to make it work, we'll just drag this QR code around the desktop. We'll put it in the lake, put it up here on this mountain. Looks nice up there. Well, maybe we just like take a little inventory here and look at our friend the mobile dancer. So this was the Unity side of things, and we finally got, last week we got a JavaScript plugin that let us do all our Socket.io stuff to talk to our backend that is currently not working. I wonder what's going to happen here if I try to run this. WebSocket connecting. It's not going to work. Man, that's a real bummer. It's like I kind of can't work on any of this stuff right now. I mean, I guess I could scramble to set it up somewhere else or just make local servers, but I sort of don't want to. Maybe this is the universe telling me to just take the afternoon off and play Animal Crossing. Okay, well, let's look at the to-do list, see if there's anything to do after wasting so much time. I would apologize, but man, if you're watching my stream, you gotta know that it's always like this. I never know what I'm doing. So here's the real question. Will I even be able to look at my to-do? Is Glitch so broken that I won't even be able to look at my to-do list? Okay. Yeah, glitch.com. So I guess all the editor stuff is on glitch.com, but the actual project containers run at glitch.me. And so it's all busted, man. Okay, so yeah, last week we talked, or last time, was that yesterday? I don't even know, man. What did we do yesterday? Oh, we did some face tracking stuff. We tried a little bit of face tracking stuff. Or hand tracking stuff. We did hand tracking stuff yesterday. And then I decided I didn't really like it. And I don't want to deal with Facebook and don't really want to deal with Snapchat and all this stuff. All of this stuff points to me to say that for remote users, we keep things very simple. But maybe for people that are in the museum, they're gonna do something physical, and maybe we'll use a RealSense camera. So I should probably get one of those pretty soon, maybe like this week. And I think one of the streams we do next week, maybe we'll even do a little bit of it tomorrow, is going to be about concept development and about gathering reference and things like that, building a mood board, style board, all that kind of stuff. because I think those are useful skills, and also I need to do it. Like, it's got to happen. So, knowing that our server is offline, are there any other pieces that we would be interested in tackling at the moment? Yeah, in the concept development realm, we need like mood, style, boards, a music playlist. I got a recommendation from my friend David Lobser. I think it's smart. Like playlists that are sort of evocative of the music. Yeah, okay, so I am kind of, if we were going to start thinking about local, definitely kind of interested in this. So I don't know that this is the best option, but it seems affordable. And it's like hyped by Intel a little bit. So Intel has this camera, if you're not familiar, called a, what is it? D435i is the one with the integrated IMU. How much do these cost? I feel like I should be able to get this on Amazon. Wow, that camera's awesome. Let's get this one. So this thing, this is like, it's not the exact same. I think it uses slightly different technology that I don't know that I could completely explain the difference right this minute, but it is something like a modern day Kinect. So like the original Kinect came out close to 10 years ago now. And even though what it was kind of known for was skeletal tracking, that really wasn't about the hardware, that was about the software. The software could do that. I don't think the hardware had any fundamental knowledge of that. I think the hardware was really about an RGB image, just like a normal camera, and a depth image. Like a black and white image that indicated the depth of a scene. And the way it connected it, it sprayed IR all over the place and then looked at that pattern and figured out like, oh, that thing's further away. So you would end up with something like, let me misspell that. Image. Something like this. So a 3D representation of a room, but it's a little funny. It's a little weird because it's like a one-sided 3D representation. You can also represent that depth with color, but it's pretty weird. And those black spots are sort of shadows where you couldn't figure out what the depth was. But that's still useful. And so one of the cool things, there were lots of cool creative projects that came out. I kind of really don't like the Kinect in general. That's what the IR pattern looks like. Or something like that. But the, in addition to all of the 3D laser scanner, what, do you know what it was? Was it like some kind of LiDAR setup? So there is a RealSense camera that is LiDAR based. So one of the coolest things that came out of this though was Depth Kit, which was a way to shoot volumetric video basically. And the idea was sort of you'd pair a nice camera, like a DSLR camera, pair it with one of these depth cameras, and then you would shoot video that would give you both depth and RGB. Now, it has a look for sure because there's so many artifacts. It's really not very clean footage at this point.
The stories you tell should bring us.
Like, so when we shoot this person, you're capturing, yes, you've got this mesh that's built. You have pixel depth data, and that can be sort of turned into other things, or point depth data. So then, yeah, you have like this weird representation of a person, but it's only kind of the part you can see. And the edges, unfortunately, aren't very clean, and there's lots of other problems, but there's still some pretty cool stuff you can do. And there has been some, yeah, like it's a little weird on these edges. You know, you could maybe imagine that one day this is used for really true experiences, like true 360 captured depth experiences. But right now even now, some cool stuff has happened with it. There's been a documentary made from it, but it is very finicky and experimental, let's say. the range is very short. So it would unfortunately probably not work well on a huge landscape without like an enormous array of images. You could, although, you know, actually, now that I say that, Google has some depth data and has recreated cities and stuff using that kind of thing. So that's kind of how Google and Apple kind of have something similar by having depth data for certain cities where they can recreate them from the imageries they have, which is pretty cool. In many cases, though, I think they're custom 3D models. They're not just purely created from the depth. Maybe for fancy cities, really high-profile cities, they do custom models for those things, New York City. But other places, even with lower fidelity, you can still generate it from the image and some depth. Yeah, you can do some cool stuff with it for sure. So, and definitely like Kijiro, who's a Unity, I think Unity Evangelist is his actual term. His Tumblr, I think is his. Has been doing lots of stuff with these depth cameras. He does like amazing VJ kind of setups. Is it you? Was he like writing weird procedural dance animations? That's exciting. Oh boy. Oh, he's back to doing cool hair. Beautiful, beautiful hair. But he had also recently been doing a lot of depth-based stuff. Oh, I haven't tried this. He is continually making amazing things at all times. Yeah, definitely. He's definitely a person, if you're interested in creative computer graphics, he is definitely, create with Unity specifically, he's definitely someone to follow. Man, he's just always doing cool stuff. He's always doing stuff that's awesome. I'm trying to find, he is a little too prolific is the main problem. But relatively recently, ooh, that's cool. I want that. I want that. Photix video light. How much for a cool Photix video light? What is it? Can we see the model number? I don't think we can quite see it. Oh, why don't you post the model number? It's not this one. For those, for which? For LASP or for whatever that weird generates? Like lots of these are just audio waveform visualizations. I don't even know. Yeah, this stuff, the wave function collapse. Yes, he's been using that for building these mazes. So he's been, I don't know what algorithm he's using. Like if there's some commonly known, I don't know much about it, but he sort of built them fully into really amazing Escher-esque environments. I'm sure he wrote all about it on the GitHub post. Oh, so he's using this. Oh, cool. So this other tool by whoever this is. That's cool. Maybe I should use this for something. Pretty amazing that it can be applied to 3D. Oh man, okay, now I have to get into this. I think we might have to get into this. Do we have to get into this? For something for the residency, I've been kind of imagining, I could imagine some of the weird like celestial trails and things I want. I could kind of see that. Okay, ignore that for the moment. Tell me what I actually want to look. Yeah, I don't know. Like I think there's two schools of thought on that. Like something here's a problem I've often had in creative projects, and especially in the past, was I want to do this. Like whatever, I want to do this thing, whatever it is. Say it's this wave function stuff. But then I would have part of me say like, oh, I can't do that until I'm good at X, Y, or Z. But I strongly believe that the way that you get good at things is by doing them. And so I have so many ideas that I never did, especially late in my 20s, that I wish I would have just done, because maybe they wouldn't have been perfect, but I would have learned from them while doing them, and they would exist. So like, I feel pretty strongly that if you want to do something, not knowing how to do it shouldn't be an excuse. I mean, I feel like you would learn by doing it. There's no better way to learn. You would learn a lot about C# just from trying to do this stuff. Is this the one? $100. No, that's not even the right one. Okay, maybe they just don't have that one. What is the model number? I can't see it. Kijiro, why do you do this? Why do you post things and then not say what they are? Why do you treat me like this? Okay, we're never gonna find this stuff, are we? We're gonna keep getting distracted by all the cool stuff it makes. Whatever, maybe we'll just get distracted for 10 more minutes and then call the stream over. Okay, yes, that's all the wave function stuff. Oh, okay, here we are, some Depth Kitty stuff. He was doing, okay, the thing I'm actually looking for is he was using Depth Kit with the visual effects graph in Unity to do very lovely things with a whole lot of particles. And in my mind, this was all like yesterday, but it's clearly not true. It's clearly, we're like several months away now. Okay, how long till I give up? Never. So this is radiumsoftwaretumblr.com. I'll just throw this in the chat because I think it's great. No, it does make sense. Like it can be, you know, there is also wisdom in saying you gotta walk before you can run. I think that's true too. But I don't know, there's any project of high complexity I feel like is reducible to pieces of lower complexity that are manageable. But I feel like for myself, for sure, whenever I have something like that, I never wait till I'm good at something anymore. Maybe I'll never be good at it. Maybe I'll never be good at anything, and then I'll never make anything. So I just have to continue making things while not very good at them. Oh yeah, so this is some Real Sense stuff. So he has some kind of library he's released for it, which is pretty cool. Like he's doing weird procedural stuff over the tops of these. These are done with an Azure Connect though. Which an Azure Connect is much more costly. Not much more, but more than twice as expensive, I will say. So I don't know, maybe that's what I need though, because that does seem, there seems to be some, we're never gonna find anything. Okay, well we found this at least. So this is lots of cool, so this is Azure Connect stuff. So he's doing like cool, yeah, he does attribute maps and then that can go to the visual effects graph. So she would release videos maybe and not these tiny little GIFs. It's pretty awesome. Yeah, so I'm definitely into that. And I could definitely see wanting to do something like this. Not exactly like this, but something, so like the themes that I'm interested in, I'm trying to build something for the Children's Museum. I want it to have some function that works now while we're all in isolation that everybody can do with their own phones, and you get some representation of like your being on the screen, and all of those representations work together. But when you're in the museum, I want you as your physical self standing there to be represented on the screen in some way. So I think it feels very promising to try some things in this realm. I don't think I'd want it to just be pure abstraction though. Excuse me. I would want to know something about movement and maybe use one of these skeletal tracking libraries so I can know where your limbs are, at least where your hands are, so your hands could do things. Because I think there's lots of potential, and I think that people haven't seen a lot of stuff like that. And I think something, again, not quite like this, but in this realm where you're recreated as like a beautiful mesh of particles kind of thing. I think there's something to that could be beautiful and interesting as part of a bigger piece. So the trick though, I've gotten conflicting reports really on what's the better device to use. The Azure Connect or the RealSense camera. The RealSense is much less expensive. They both use slightly different technology, but they function in different ways. But the thing, actually, he probably has. So no Linux support. I thought he had a repository for RealSense, but I could be all wrong. Am I a crazy person? DepthKit. But what hardware are you using? Yeah, so this was DepthKit. So this is... Okay, well, I can't find exactly what I'm looking for, but I feel like the thing that I came away with was that DepthKit, which these seem to be the people to trust in terms of like what to do with for these kinds of volumetric capture. Recommended computers and supported depth sensors. According to them, the RealSense camera is not great. Yeah, so they have experimental support, but it says they've observed stability issues and lower than acceptable data quality. So that, that's 10 months old, and that's just one piece of software saying it. Maybe that's just their own support isn't very good, but like, feels like a little bit of a worry. I really thought Kijiro had some RealSense stuff though. So you're usually, okay, switching from RealSense to DepthKit. I don't know, man. I'm a bit torn on this. So, okay, maybe this is the project I'm thinking of. This one was RealSense depth camera. RSVFX. This guy? This is what we want. Yes, the RealSense depth to visual effects graph. So does this mean a D415 is better than a 435? I thought bigger number meant better. Isn't that the rule of life? So, bigger number not better? Is my whole life a lie? So, say I was just a interested consumer and I wanted to purchase a D415. First, you type the numbers correctly. This is the first thing I recommend. And then separately, I recommend searching. Do not think we want to make a purchase from Walmart. So from Newegg, 157. What is this thing? Oh, those are modules if you're going to design your own hardware. Okay, but we're gonna say in the neighborhood of $160 versus one of these friends. Boy, those seem to cost a lot. I can get a free account. Buy now. 400. So like, yeah, more than twice as expensive. Save a little bit of money for eligible. What about nonprofit children's museums, huh? What about that? I don't like the footprint of this thing though. I gotta say, like if you're gonna put this in front of a screen where people can, so they can interact with it, then like you've got kind of this big goofy thing in the way, right? Like that feels less than ideal, I want to say. Okay, I'm gonna call it for today. The last hour was, I don't even know what we did, but we did some more thinking. Right now, if you had to ask me right now what this project is gonna be, it's gonna have a remote component where people will interact with it while moving their bodies while holding their phone. If you had to ask me right now. And it's gonna have a in-museum component that is driven by, let's just say it's an Azure Connect. I just need to look, we just need to know. Like who wins? I'm so tempted to just trust the depth kit people though. Right? Like though these are people that have been doing like creative capture, including James George. Do you also need a camera, or can you just use the camera that's in the thing? I think we need to get it. I think we got to get one. They got some cool stuff. I think we do it. I think we do it. I think that's what this is going to be. Okay, we're going to think more on this. Sorry for the weird stream. I mean, we did the thing we were supposed to do. The whole second half was just whatever. But look what I got over my shoulder. There's a machine over here. I've got turnips to sell. I've got important work to do. I've got like hundreds of thousands of bells worth of turnips. I got to move, and I don't have time to work. That's not true. I need to work on other things actually. Okay, we will talk again soon. We'll talk tomorrow about more of these things. I think I got to get one of these cameras. I think it has to happen. Okay, have a lovely day. Thanks for hanging out, everybody who stopped by. Thanks, Wash. Thanks, Dracklin. And we will talk next time. See you later. Bye. Ben, you were here the whole time? Ben was here? You thought you could sneak in at the last second? Oh, what a creep, lurking around. Actually, you know what I'm gonna do? Well, we don't do it this time. We'll do it another time. Okay, we're gonna be done. We'll pick up next time. Have a lovely day. Man, Ben, you just watched me like ramble for about nothing about cameras for whatever for the last hour. Okay, I have serious questions about your viewing choices. We will talk soon. Goodbye.